Hello, hello everyone. Hello everyone. Hope all is well. Thank you a lot for joining us today for this special webinar. And currently, I'm joining actually from Sydney. I'm also joined by my co-host Imad for today. We're just going to start first with an introduction about about our program, and then we're going to move towards our specialists today who are joining us concerning data analytics for both wind, offshore wind, and batteries storage. So today we're having a webinar about data analytics and renewable energy in general. And data plays a very big role in renewable energy because it supplies a kind of a feedback of data that allows us to do preventive maintenance, optimize, even find problems that weren't expected in the initial EPC design or by the O&M companies. So there's a lot of benefits that come from data analytics and renewable energy. But in particular, we're going to focus today on offshore wind and also battery storage data analytics. So in total, today's webinar is going to be around 75 minutes. And as our guests, you'll be muted during the presentation. If you have any questions, feel free to post them on the Q&A function. And after that, we're going to send you a survey. So let's begin. So today, our agenda is the following. We're going to have first our introduction, which we're doing now. Then Ithaca Clean Energy will join and talk about data analytics for offshore wind. And he has a very interesting presentation about that. Then we're going to have a 5-minute break. Then we're going to be joined by Powerup, which is a very interesting company specialized in energy storage and data analytics. And sorry, we have someone muted. Can please? Also, we also have at the end, we're going to have Q&A sessions, and we're going to end with ending notes. So let's start. So just an introduction about our program. So we're basically like a platform. ENECHANGE Inside Renewables comes from the listed company ENECHANGE, which is a data analytics company based in Japan. And also we are a renewable energy company in investment. We've actually done a lot of investments as well in renewable energy across several countries. So the ENECHANGE Inside Renewables program stems from the facilitating connections. And we have a team across our offices in London, Tokyo, and Beirut, multiple geographies, and also a support team spanning 15 countries, where we help developers and specialists meet investors that are like-minded and help facilitate actually the transaction in a sense. We harness our specialized our knowledge in investments and M&A and help assist with that transaction in a sense. But so we have a database filled with renewable energy opportunities from around 140 developers. We have monthly webinars with developers and also specialist webinars, which are open to anyone to join, like today. And finally, we're setting up a summit where we're going to have investors and developers meet up together, because it rarely happens in exhibitions and conferences. Usually it's more of specialists, or it's more of products and manufacturers, and rather than directly developers meeting investors. So in our platform, we currently have around 37 gigawatts of opportunities. And we also have around across multiple spaces, like basically solar, wind, solar and storage, hydro, hydrogen, and all. And we have around 130 developers on board, and opportunities spanning from early stage, greenfield, middle stage, late stage, and even operational, and even small scale and large scale, utility scale, and even communal. So our current opportunities are available across multiple geographies and main countries actually of interest across Europe, US, North America, South America, Africa, Europe, Southeast Asia, and Australia. So we're gonna be currently we're gonna be joined by Ithaca Clean Energy, presented by Khalid Kamhawi. But before that, we have a question to the audience concerning basically general information about wind. So please, if you can participate, it's about the available power of wind over the surface of the earth. And if you can give us an estimate about how much is it in terms of capacity. You can vote, by the way. So, and you can pick one choice. We'll give you like a minute. Okay, so basically the results are, okay, correct. Most people got it. Today our guest is going to be Khalid Kamhawi. He's a specialist from Imperial College. He's the founder of Ithaca Clean Energy, specializes a lot in offshore. Offshore, and basically he's going to be talking us about his company and how he's utilizing data analytics in the field. Khalid, can you hear us?
I can hear you fine. Hi. Excellent. Thank you very much for the introduction, and hello everyone. My name is Khalid. I am the founder and CEO of Ithaca. Ithaca builds digital solutions for offshore wind. I'm here to talk to you about data and analytics in offshore wind farms. I'll start by saying that about 2 years ago, I was in a presentation and I gave a wager. And I said, in about 5 years' time from now, no engineer will be employable without a background in data analytics. I would argue that either I'm proven to be correct because it's necessary, or I'm proven to be false for one reason only, is that maybe AI will take over that role rather than people. So I will have another wager to make in a slide or two, so stay tuned. So maybe the first thing I am going to mention is what are the actual specific drivers towards digital transformation within offshore wind? And I would say that there are a few, but these are the ones that, in my mind, are the main ones. So you have the commodification of materials. You know, steel prices and other materials, if you're in floating, are commoditized. So it's very difficult to really capture a cost advantage there. Also, although you can argue against it in floating for now, but there is a convergence of technologies. You know, most fixed bottom turbines are of the same structure. Obviously, you have different selections between monopiles and jackets and other substructures, but the turbines themselves are also very, very similar in terms of design. So there is convergence there. So you can't really distinguish yourself in your design parameters. Also, there is serial production. and that's a paradigm. Basically, you need to produce a lot of the same thing, and a lot is relative here, but for commercial to utility scale projects, 70 units and above. Obviously, the intermittency of the wind, which has a lot of uncertainty associated with it, but also some kind of, I call it electrical dumping. And maybe actually the second panelist can give us some clues here, but there isn't a long-term electrical storage solution yet. So basically, when you produce your electricity for an offshore wind farm, you need to connect it to the grid, otherwise it's lost, right? And finally, integration into the blue economy. Now, we shouldn't forget offshore wind is a green industry, but it also is a blue part of the blue economy, and it needs to be part of that ecosystem. Now, all of these things end up having offshore wind with razor sharp profit margins. You do not make the large profit margins as oil and gas do, so you always need to distinguish yourself moving forward. So here's my wager. My wager is digital transformation will be the defining innovative factor for offshore wind profitability in the near future. Yeah, so if you want to be profitable, you need to have a digital transformation exercise as a company. Otherwise, your margins, which are very, very razor thin, will be eaten up by your competitors. So where are we in the industry in terms of digital transformation? And I want to make it clear, and I'm sure many of you know, but there's a distinction between terms here. So there is digitization, digitalization, and then digital transformation, and they are different. So digitization is basically turning all of your analog information or data into digital information, right? It's actually turning information into accessible units. Digitalization is actually amending your systems to become digital, right? So that they deal with that digitized piece of information. And the final one, which is your ultimate goal, digital transformation, is when you actually convert your culture, so the way that people work, not only your systems, into a culture that has data, within its DNA. So where we are now, we're at the very beginning. And I can give you a very quick example. So there's a client that I provide some consultancy work for some specific, very, very specific items to do with foundations. And what we were talking about, how you can access all of the data for each and every TP for its project. And the way that they do it is they just put that information in an Excel sheet. Although you do need to have that information in an actual database, and that database needs to be relational so that you can access that information in a much more efficient way. And we are still at the Excel sheet phase. So this is the slide that I think I'll spend slightly more time on. So ultimately, these are the things that I think are the most important categories in which the digital transformation will show itself in. So the first one is offshore wind farms need to be integrated into the blue economy, which means you need to have dynamic stakeholder engagement. This is the main reason why permits are delayed. And this is the main reason why offshore wind in the US is lagging than in Europe, because the first commercial scale project was cancelled because of all of these impact assessments against stakeholders. The second one is project digital twins, and here the concept to note is project, because there are digital twins out there. Obviously, turbines have their own digital twins, but these are asset digital twins. What I'm referring to here are project digital twins, where you actually digitize the actual project process itself, all of the decision points, all of the design work, all of the execution works. So you want to mirror the whole project and historically track it so that you can be more efficient when making decisions in the future. The next one is data-driven financial models. So, for example, when you want to build your financial models for CapEx and OpEx right now, what people do is that they make a single assumption about the steel price, for example. What you need to do ultimately is actually connect your steel price with the actual projections of the market. So, and your model needs to be dynamic enough to track that. I'm sure maybe some investment arms have this information, but working with some project developers, I do not see this is being deployed at all. The next two are quite important. The demand-driven asset sweating. Basically, you want to link up your operational protocols actually to the price of electricity, so that you can conserve your fatigue life and basically sweat your assets or push your assets to produce when the price is high, and actually conserve your fatigue life when the prices are low. The last one is actually pivotal and will prove to be more and more important as the years progress, but energy cybersecurity is vital. For example, in Europe, we know that energy security, in the sense of moving towards renewables rather than relying on external oil and gas, is important. But once these projects are built, you actually need to also defend them and to make sure that they're not hacked and they're not manipulated through data systems. So you need clear cybersecurity protocols there. My company, Ithaca, we are actually now building solutions for the first two of these items. This is one other example. This is to do with how you can actually build a fuzzy supervisor control system for a floating structure that can maximize energy production or yield for a proportional integration controller by pitching the whole system based on the wind input. I just put this one here to stimulate some thought processes. Some systems can be quite sophisticated for data analytics. So here I'm going to talk about Ithaca because I was asked to actually introduce the company. So Ithaca has been integrated in the US ecosystem. We have been part of the National Science Foundation National Cohort Program and Massachusetts CEC program and others. And our first solution is to deal with stakeholder engagement. And as you can see from this slide, stakeholder engagement is very complex and busy. These are very expensive and complex infrastructure projects. You need to deal with stakeholders from fisheries and port authorities and others throughout the life cycle of a project. And why do you want to do that? Because you want to address permitting negotiations. You want to always be aware of any exclusion zones during any offshore works. You also want to have an evidence-based claims and compensation process. And ultimately, you want to have a real-time sharing of inspection maintenance campaigns with communities so that you can avoid any downtime due to blocking your marine activities from stakeholders. So we've built a real-time, streamlined, free app that links any marine stakeholder with the offshore wind farm to get project-specific information, which is visually represented on a map and allows for engagement between the two parties. Actually, fishermen can pin their gear on the map and share that information anonymously with offshore wind farms so that they can avoid damaging that gear. So these are just some visuals of how the app works, and you know, any of you can go on the App Store or Google Play and download these apps. Ultimately, when these apps gain critical mass, you will have a marine network effect where other parties within the ecosystem would want to be part of that network, from ports and harbors to the coast guards and the navies, to supply chain and vessel owners, and also marine research from universities and aquariums. The final thing I'll talk about very quickly is our second product, which actually is building a project-based digital twin, where you don't only track the assets data, but you track the projects data. And here I have a very quick representation of the system, which is a 3D interface, which captures the whole timeline and life cycle of a project. And obviously it can integrate into the assets digital information, but also from a global perspective, anything to do with how the project is being built. You can also track the health status of each item. It's electricity sending, its electricity transmission through the grid, and so forth. Okay, let me go to the next slide. And we've also built, this is in a very early prototype stage, but also a VR through your tablet, where you can visually represent the actual space of your wind farm in a 3D manner. We believe this has some design utility, but also some utility if you are offshore on a vessel, and you know, once we develop certain standard ways of measuring your distances, you can see through fog, for example, through these systems. So thank you very much for your attention, and if you have any questions, obviously please be in touch. Thanks very much.
Thank you very much, Khaled, for this presentation. As he mentioned at the end, any questions that you have, feel free to type them up in the Q&A session, in the Q&A bar, and I'll be sure to share some of the questions. Starting, I would like to ask a question concerning firstly the potential economic benefits that the offshore wind project can benefit from your analytics solution. If you can tell us a bit more on that.
Yes, of course, and thank you, Ahmad. So, for example, for stakeholder engagement, offshore wind farms in the US, for example, the first commercial offshore wind farm paid fisheries $19.2 million in preemptive compensation, and that payment wasn't based on any kind of evidence. It was based simply on political negotiation. Now, we don't know whether that number is high or low. Maybe they've overpaid, maybe they've underpaid. But once we have the digital assessment of where the fishermen go, at what times, how the marine activities of the offshore wind farm would actually impact their work in terms of fishing effort, that's when you can really tell. So having this evidence can really affect these numbers quite substantially. Another quick one is that Vineyard Wind was delayed by 1 year in terms of its permit due to stakeholder resistance or obstacles that they've put in. Our estimate is that every 2 months of delay will cost the project around 50 million in lost energy generation. So you know, multiply that by 6. Yeah, so that's a lot of money.
Indeed, that is.
Yeah.
And what about at the moment? Obviously, you're still developing more and more on your projects, but how do you see your applications or your technology improving the efficiency or the effectiveness of the wind operations?
Yeah, thanks. for example, our stakeholder engagement app Waterfront is being deployed by 3 projects already in the US. And as we know, we only have Vineyard Wind as a commercial project being currently built. So they are deploying this quite early because it is facilitating their engagement with fisheries. It is allowing for a mutually beneficial space to happen between them because they can plan better and they can also compensate each other based on information. Now, I'll mention one more thing. Actually, we have the Bureau of Ocean Energy Management, BOEM, which is the federal body that actually dictates what the requirements are for engagement. They are also our client, which is an indication that communication between the different parties and sharing of data and information is vital for the future growth and deployment of the industry in the US, at least. Thanks.
Great, thank you. And one last question that's more about offshore wind in general, but one of our attendees had a question on why is it important to create the exclusion zones around the offshore wind turbines for the fishermen?
Yes, that's a very good question. And now some projects in Europe, the exclusion zones are imposed by law. However, in the US, exclusion zones are only imposed during particular stages of a project. But ultimately, the point is it's for safety reasons. So you need some exclusion zones sometimes during heavy marine activity offshore, especially during actual installation. So you don't want people to actually be hurt. Other times you might have some difficult weather conditions, so you want to avoid collisions as well. However, with technology and with the ability to share information in real time offline, also where people can preserve that information on their tablets and they can access it when they are offline, will allow people to navigate better. So it creates what's called situational awareness. And with situational awareness, you can avoid these potential safety hazards.
Great, perfect. Thank you, Khaled, for the answer. And if anyone else has any further questions, feel free to send me an email, send Khaled an email, and we can connect you with each other. So thank you very much, Khaled, for your participation, and any additional information that any attendee would like about Khaled, feel free to ask us.
Thank you very much, Ahmad, and I appreciate the opportunity. Thanks.
Of course.
We will be hosting our second guest, and it will be by Powerup, and it's going to be about data analytics and analytics solutions for energy storage. And storage has been a very, very important topic. It's actually one of the hottest topics going in renewable energy. And there are a lot of questions about the quality of the lithium-ion batteries there, all the alternative storage, vanadium redox, or other like alternative thermal storage or other methods. And I do believe that in the next few years to come, you're going to see a lot of alternative storage methods and alternative ways to do it. And taking care of the battery is very, very important in the sense that if you don't take care of your battery through temperature, humidity, all of that, your actual investments of a battery, their lifetime will go down, deteriorate rapidly, and you'll end up with very disappointing results compared to the manufacturer. So we have a question for the audience who are joining us. Actually, 2 questions for the audience. So if possible to answer them, and feel free. The first one is, what is one of the applications of data analytics that helps in optimizing energy storage systems? One answer is, the second one is, what applications of data analytics in the renewable energy field helps optimize maintenance schedules and reduce downtime? So we'll give you around 30 seconds to check. And at that time also our guest is preparing himself for the presentation. Okay, I think that's good. Oh, we have a spread. So basically, like in the opinion of our guest, of our guests, basically battery health is the number. They care about battery, energy demand forecasting, grid stability analysis. I'm actually surprised about that because grid stability is the one of the most money-making businesses for battery storage, especially in utility scale. The second one is actually predictive maintenance and energy demand forecasting. So there's like a mix, but mostly towards predictive maintenance. So that helps our presenter figure out where our guests are standing at in opinions. So just introducing our guest speaker. So we're gonna be introducing Philippe de la Fortelle, and he's the Chief Revenue Officer at Powerup. He has a very extensive experience merging between technical and the financial world through an MBA holder, and he worked for several prominent companies like Ericsson and FXFO Group, and has a good mix between SaaS products and also pricing and management. So he probably have excellent experience in the field. So I'm gonna stop sharing my screen for Philippe. Hello, Philippe. How are you doing today?
Hello. Can you hear me well?
Yeah, we can hear you loud and clear. Where are
Excellent.
you joining? You're joining from France at the moment?
Yeah, absolutely. Located in the center of Paris right now.
That's great. I'm currently far away in Sydney, and we have our guests all around locations. So if you can do a heat map, it's extensive. So please start your presentation.
Very good. All right, so let me share my screen. Hopefully you can see it by now.
Yeah, we can see your screen.
Excellent. Yeah, so really thanks for inviting Powerup today on this
if
webinar.
possible, can you share your other screen? Because I think by mistake you shared your other, you are using two screens, and you shared one screen which has the other one.
Let
Usually
me try again. Yeah, so I think there is a good consistency between what we just heard, great presentation from Khalid, and I think there again we are discussing about data and how to make the best use of data that you're collecting in your assets for using those assets with the best efficiency, the best safety, and the best profitability in the end, because that's the name of the game. And I think here we are we're really using that same central discussion point, however adapted to battery storage, as Kani introduced just a few minutes ago. We're focusing on lithium-ion battery storage systems and how will analytics help you make the most out of those battery assets. Now, yes, of course, there will be alternative storage technologies, that's for sure. However, when looking at what's going on the market from now on until 2030, I mean, it's unbelievable the growth that we can see happening on the market just looking at lithium-ion batteries, and I think this will remain, the massively used technology, at least in this decade. That's the decade of batteries, And of course, many different applications will use those lithium-ion batteries. A great majority for mobility use cases. However, a certain amount in stationary, which is absolutely not insignificant when applying this percentage to a huge market in terms of terawatt hour of capacity being deployed all around the world without exceptions. And so this huge capacity that's going to be installed, and that's already starting to be installed, but will accelerate even more in the next years, has challenges. And I think that's where Powerup is being positioned today. The value proposal that we've been building is all around 3 different axes: safety, performance, reliability, and durability. And so I will really focus on those 3 axes all along the presentation, and you will see that I come back to those 3 notions all along. Why safety? Well, I think that's kind of the obvious question, right? Safety has been top of mind for all asset owners, developers, integrators, because unfortunately, although the probability of seeing those events, those fire events happening is low, they still happen. And when they happen, you know, it's a real catastrophe, because obviously we're talking about it in the news. Sometimes, unfortunately, there are casualties. This technology has a safety implication, which is important and which needs to be tackled, because the investments are huge and you don't want these investments to be impacted by those safety events. Now, very quickly, when you talk about safety, you also quickly go on the performance topic as well, because before seeing a safety event, the degradation of the batteries affect the performance of the assets. And very, very often, prospects and customers come to us saying, well, I'm not very happy with the performance I get from existing systems. You can see acronyms on the slides: SOH, SOC. These are critical measurement criteria. SOH means state of health. SOC means state of charge. And those 2 KPIs together make it possible for you to know what is the energy quantity available in your assets for the different use cases that you have to deliver. And a difference or an issue in accuracy in determining those state of health and state of charge measurements is immediately affecting your profitability and your revenues. And so having the best accuracy possible leads you to having the best performance in delivering the use cases and then eventually getting the revenues from your assets. Finally, endurance. You want those big investments to be leading to the largest lead time, the largest useful lifetime, from the beginning to the end, and that can be 10, 15, 20 years of project performance, from the initial design phase and up to the end of the first life, and potentially even leading your batteries to be used in the second life afterwards, etc. So endurance is the name of the game. If you can prolong your assets, then you will have more years of revenues, more years of profitability, and a better use of your initial investment. And that starts from the design phase. If you manage to design your assets to be correctly fitting the use case that you're delivering, then you can not only have a good endurance in time, but also save cost from the very beginning. So that's that's also a key factor in what we are delivering. basically to synthesize what I've been talking about and to kind of position Powerup in the value chain and also insisting on what is different with what we deliver. Again, talking about safety, performance, endurance. While most systems today on safety are able to detect an issue very, very quickly before an issue would happen, and again, not being able to stop it in most of the cases, what we provide is a key ability for preventive maintenance. Coming back to the poll we had a few minutes ago, we are enabling a real preventive maintenance capability to avoid thermal runaway and the fires that can happen, because we can detect very early signs of degradations that are actually the root causes are mainly cell imbalance and lithium plating. We'll come back to that. And we can detect the early signs of degradations months in advance before that would lead to a potential fire event. And that's key for enabling preventive maintenance and having the maintenance activities implemented in due time and leading to great cost benefits. On the performance layer, again, we're coming back to accuracy issues, and we can do much better than existing systems. We can provide and guarantee a much better accuracy by a factor 5, and that leads to immediate profitability and revenue improvements. Finally, while most battery manufacturers today provide a data sheet with static projections, what we will focus on is creating this digital twin concept, taking into account the real usage of the asset, and also being able to adjust this usage to an aging model that we have determined, and the two together make it possible to make a real forecast, an accurate forecast of the dynamic lifetime until the asset would reach its end of life. Excuse me. So how do we get there? Well, Powerup is fortunately having a strong technical heritage. We are a spin-off of a well-known research institute in France called the CEA that's been spending a lot of years doing R&D on lithium-ion batteries. And we really benefit from this technical heritage because this intellectual property we are using now in the product that we are proposing. And not only that, we've also improved it by creating our own patents, as an example around safety. And so we are now in a position to have a non-intrusive battery monitoring, battery analytics solution, providing best-in-class accuracy KPIs, actionable KPIs to our customers. We've been able to field-prove our solutions with a number of large companies in France. And today we are accelerating our international expansion. Some of the recognitions you can see are truly international. The last one with an American research institute, the EPRI, that selected Powerup among hundreds of startups coming from the entire world. And so we're still a small company, 30+ employees, but growing today very fast in the field. And again, having a strong emphasis on international expansion. Our product portfolio has been evolving in time, starting in the first years of the company with customized hardware solutions that were able to prolong the lifetime of lithium-ion batteries used for backup solutions in the field of UPS. Gradually, we've been extending that towards becoming more of a software company today. First of all, extracting the software from those hardware solutions to be able to load those embedded libraries into any kind of hardware in our customer solutions. And since last year, putting on the market a SaaS platform, a cloud-based solution, which is enabling us now to address stationary storage, fleet management solutions, and staying also in the field of the backup and UPS systems. Thanks to that, we now have the capability to not only implement our system in the central cloud position, but also having the possibility to implement local edge-like solutions in mobility applications, or even closer to the assets themselves, playing on the fact that we would have local computing capabilities as well as central computing capabilities for the best architecture possible, and to use the computing where it's best fitted. And you saw in my background, I had a strong telecom background, and I think that's exactly the movement that the telecom applications had in time, trying to find the best splits between central computing and local computing. And I think the energy world will go that route as well in the years to come. Excuse me. So that's our SaaS solution. We call it Battery Insights. And so we are simply using the data that is already produced by the battery management systems, collected by asset owners or asset integrators for maintenance applications, and usually stored in clouds or in local servers. And we are simply extracting this data for our own benefit, using this data in our algorithms, and then bringing back the results in the form of safety KPIs, performance KPIs, and durability KPIs back to our customers, thanks to AI and machine learning applications. And we are able to either dispatch the results on our own front end or integrate our results on an existing customer dashboard through APIs. And so these are the three steps: data collection and storage. We are simply using data that exists, current, voltage, temperature, time series, usually on samplings of 1 to 10 minutes. Then we are cleansing, processing the data so that it will be, removing any abnormal values, or simply, making sure the data is correctly set to be integrated into our algorithms. And then using those algorithms, bringing back those results in a usable format, in a very clear format, everything on one simple screen, so that you can track the performance and directly get maintenance activities organized for the best usage and for the best profitability of your assets. Finally, one last slide to present you a little bit how the data can be displayed on what you would get out of this product. So that would be your control platform that you would be seeing modified day after day, with alarming systems that would send you alarms whenever an issue would be detected, for instance, on safety. So you'd have safety indicators on the top for over temperature, over under voltage, or cell imbalance issues. So you'd be immediately informed about the problem, so that you would take immediate action in the case that would be a potential safety issue on one of your assets. Excuse me. You would also be able to track the performance characteristics of your assets, on state of health, state of charge, and what we call remaining useful lifetime. And you would be able to track the usage, make sure the usage is within nominal conditions to avoid any warranty issues, and to be sure that you're having the right cycling, the right temperature, and all the right usage conditions for making the most of your assets and making sure you're not going into the wrong side of things. And you can see you can track that at the ESS level, the entire assets, at the container level, at the rack level, at the module level, so that you can really pinpoint where the problem is at the lowest granular level. And with that, before my voice completely disappears, I would just say thank you very much for listening to me. And I'm really glad to answer any questions, either now or later by email. You can see my email on the screen. Thank you very much. Iman, I think you're on mute.
Thank you very much, Philippe, for your presentation, as well as for participating in our webinar and sharing more about Powerup. Given your situation with your voice, I won't hammer you with a lot of questions, but we have a question firstly from our attendees. If you can tell us a bit more about what measurements or actions have you done for this battery safety and performance, so for the state of health, and how do you think you are improving the battery performance through your software?
Great questions. Thanks, Iman. So we are constantly helping our customers assess the safety level of their assets, right? And not only on continuous measurement, but also on, I would say, measurement of data after an event has happened to prove them that our systems could have detected the safety event if they would have had our solution implemented. And so we were able, for instance, to prove points that on a real safety event, we were able to detect early signs of the issue up to 9 months before the issue really happened. So that's truly interesting, because 9 months give you plenty of time to organize the maintenance, to organize the swap of modules, and make sure that your safety event is under control. On state of health, we can see, for instance, situations where within an asset, some racks or some containers are unfortunately having much lower state of health than the other containers and other racks. That's due to what we call accelerated aging. And that can be because of, for instance, cell imbalance issues. And sometimes those cell imbalance issues can be actually sorted out through a rebalancing procedure. And so you can gain back capacity, and you're able to make the most of your asset. You can gain up to 10 points of state of health. And so that's potentially hundreds of thousands of dollars that you can gain back, energy that you can finally sell on the markets that you couldn't access beforehand. So those two examples showing that we can really help our customers with safety and performance.
So with battery degradation, you have found a pattern, a specific pattern with the input that you're receiving to indicate 9 months in advance. That's correct?
We have dedicated patterns on safety analysis and being able to identify cell imbalance degradation issues that can be of different natures: dispersion of capacity, dispersion of resistance, dispersion of state of charge. We're able to find out which are the root causes and provide to our customers recommendations on how to improve the situation as quickly as possible. Yes, absolutely.
Okay. Great, thank you. And one more question. concerning electric vehicles, as electric vehicles are getting more and more popular, how do you see Powerup's technology falling in the transportation sector later on?
Great question, and I think we are extremely happy to see that the exact same value proposal pillars on safety, performance, and endurance apply to fleet managers using electric vehicles. So we are analyzing fleets of electric buses, electric ferries, electric cars, or even electric robots that are actually a more industrial usage. And of course, you know, when you are having fleets of hundreds of electric buses, you don't want any of them to take fire, because this has even greater, let's say, potential issues with the risk of lives. And of course, you want your buses to perform very well, because otherwise your bus would simply stop on the road. And finally, you want your fleet to be used before reaching their end of lives, the maximum number of years possible. So this is exactly where we see the same value proposal being absolutely relevant for electric vehicles than it is for stationary storage.
Okay, so when comparing the differences for mobility and energy storage systems in terms of the KPIs that you had previously mentioned, how would they vary regarding your activity as well?
Well, as for now, the same KPIs have the same interest. Now, of course, as we develop, we will probably see, let's say, specific applications related to mobility. We will probably integrate within wider fleet management software systems, and probably the fact that those vehicles will be used in a different manner than stationary storage will lead us to develop specific features. But when you think of it with vehicle to grid, finally those fleets will be also used as storage assets. So you know, there will be a lot of convergence between the two use cases. So we feel we're very well positioned for the two segments today.
Okay, perfect. Thank you very much for answering our questions. There are no further questions from the attendees. If anyone has any questions that you would like to share with Philippe, you can see his email at the moment on the screen, and you can also contact us as well, and we would relay you back to him. Thank you very much, Philippe, for joining us, participating with us, and for being part of our webinar.
Thanks for having me. Thanks very much. Bye-bye.
Of course. So, lastly, we'll simply be concluding our specialist webinar. Thank you for everyone that attended our webinar. Thank you for Philippe and for Khaled. We will be sharing a small survey after the webinar. If you could fill it out, it would help us tremendously. And of course, any questions that you have, any concerns that you have, feel free to email any one of our team, and we'll be happy to help you out. Thank you very much, everyone, and have a good rest of your day.